Hello, everyone, and welcome to the Sky this month for September 2025. My name's Paul Martinaitis, and this show is brought to you by the Astronomical Society of South Australia. So now that we're at the beginning of spring, hopefully the nights will be getting just a little bit warmer and hopefully a lot clearer than what we've had over the last few months. In terms of constellations, it's a great time, the spring night sky. Um, Constellations such as Sculptor and Fornax will start to come into the observing window and all the galaxies within them and other fine objects. And this month, our constellation of the month will be Aquarius. So we'll look at 3 or 4 of the best objects in that region of the sky. And there's a fair bit going on in the solar system as well, in particular, both Saturn and Neptune coming to opposition. So we'll have a more detailed look at those planets and also their moons. So, as usual, we'll begin with a tour of the night sky. So, we'll begin our survey looking in the west, and we're looking at the sky as it'll appear around 9 p.m. on the 15th of September. So, that'll be during the period where the moon won't interfere with our deep sky observations. So, we can see that constellations such as Lupus and Scorpius are still reasonably well placed now, getting a little bit lower, but certainly still a good time to look at some of the fine objects in this region of the sky. A little bit higher up, we can see Sagittarius, probably ideally placed at the moment, not too high in that annoying position, right on the zenith, just a little bit lower down. Looking northward now, if we look towards the horizon, you can see there that Lyra is pretty low at the moment. But if you happen to be out earlier in the evening and you have a nice, clear northern horizon, check the Ring Nebula out. And it's really easy to find as well. All you got to do is find Vega, and then above Vega, you'll see a parallelogram, a very distinctive parallelogram of fainter stars. And if you make your way about a third of the way across the top of that parallelogram, just sweep across in your telescope with a fairly wide angle eyepiece, you'll spot the Ring Nebula. And then once you spot it, increase the magnification until you get a nice view. And it's a really bright, one of the brightest planetary nebula, and it has a really distinct donut shape. Well worth checking out, even if it is getting a bit lower down at the moment. Looking over now towards the northeast, we can see that Pegasus is starting to leap out from the horizon. And then further up, we have Aquarius, which is going to be the constellation of the month for September, and also Capricorn above that. Looking eastward now, we can see firstly just below Aquarius is Pisces and Cetus, sort of halfway above the horizon at this point, and of course later in the evening and as we move into spring they'll become higher. So pretty much dead in the middle between the circlet of Pisces and the head of Cetus is Saturn, and Neptune's really very close by as well, within about 2 degrees, I think, 2 or 3 degrees. So we'll talk much more about those two planets very shortly in the show. Moving a little bit more towards the southeast, many great galaxies in this region of the sky. There's Grus, the Crane. Of course, within Grus is the Grus Quartet, very well placed for observation at the moment. Some nice galaxies in Indus as well, a little bit fainter, but some nice, particularly edge-on galaxies in Indus, which we'll talk about in a future show. A little bit lower down is Sculptor and Phoenix, and lower down still is Fornax. So a lot of great galaxies in this region of the sky, and they will really come into view as we move later on into spring and early summer. Finally, turning our attention towards the south, lower down we can see Dorado, Volans, and Reticulum are starting to rise up, and they'll get higher again as we move into spring. There's Carina just sticking above the horizon there. Looking further up, Pavo, well placed at the moment as well for observation. One object in particular you won't want to miss out on is NGC 6752, probably the third or fourth best globular cluster in the sky. And of course, while we're talking about globular clusters, Don't forget one of our favourites, of course, which is 47 Tuck right there. We'll now take a look at the calendar for September. So at the beginning of September, now that we're coming out of winter, nights are starting a little bit later. So darkness began at 1924 and went through to around 5 a.m. in the morning. By the end of September, darkness will begin somewhat later at around 1941 and go through till around 4:30 in the morning. So in terms of moon phases, full moon was on the 8th. Last quarter will be on the 14th, new moon will be on the 22nd, and first quarter will be on the 30th. And the dark sky period, where the moon won't interfere with our deep sky observations, will begin on around the 13th of September and go through to the 24th of September, or perhaps even a little bit longer, depending on how late you want to start your observing evening. Looking at the solar system now, firstly concentrating on the inferior planets, we can see Mercury really spends all of September pretty much in conjunction behind the Sun and is therefore unobservable. And it will re-emerge. It was a morning object, and now it's going to re-emerge as an evening object in October. Venus, however, you can still catch a glimpse of in the pre-dawn sky, but as September progresses, it's going to get more and more lost in that pre-dawn twilight. And then as we move into October and November, again, it's going to go into conjunction behind the Sun and therefore will be unobservable. And it won't be observable again until it re-emerges as an evening object in early 2026 in January. Mars, on the other hand, we can see there is a early evening object. The apparent distance from Mars is already getting quite large and getting larger all the time. So Mars is going to get just smaller and dimmer as the year goes on. Certainly, you won't be able to pick up any detail through a telescope at this point on Mars. So it's pretty much a naked eye object, I think, at this point. And then again, as the year progresses, it will eventually get lost in the evening twilight. Moving now towards the outer planets, where really all the interesting action is happening. So firstly, we can see here we've got Jupiter. That's rising in the pre-dawn sky, I think around 3:30 to 4 a.m. In the morning. So that's going to get better and better placed for observation now as the year progresses and as we get towards its opposition, which will be in February 2026. Uranus is rising at the moment at about 10 p.m. in the evening, I think between 10 and 11 p.m. in the evening, and that's going to come into opposition in November. Now we're just going to turn around a bit and we're going to have a look at really the two planets that we're going to concentrate on in this show. Firstly, we have Saturn, of course, everyone's favourite planet. And that's coming into opposition on the 21st. And also we have Neptune as well, which comes into opposition just a few days later. So shortly we're going to talk in much more detail about these two planets. So just looking at a few of the planetary views now, just some of the key highlights throughout the month. So this shows you the view on the 24th of September at around 7 p.m. in the evening, where Mars and the Moon, Mars will appear there in the western sky just after evening twilight, and it will be joined by that beautiful slender crescent moon. So at the moment, Mars has a diameter, I think I said before, 2 arc seconds. It's at the moment about 4 arc seconds, sorry, but still really too small to see any detail, I think. And currently magnitude 1.6. And as the month progresses and the year progresses, Mars will get lower and lower towards the evening twilight. Jupiter now moving from the early evening sky to the early morning sky. So this shows you the view around mid-month at 5 a.m. In the morning, just prior to sunrise. We can see up there between Aldebaran in Taurus, and the Pleiades. Roughly halfway across is Uranus. So currently Uranus is rising at 11 p.m. in the evening, and it's transiting at around 3:30 in the morning. So um, that's coming to opposition in November. So we'll talk about Uranus in some more detail um, in a month or two's time. Now moving down towards the northeast in Gemini, we can see there's Jupiter. So Jupiter is currently rising at 2 a.m. in the morning and transiting after sunrise. So if you want to get a view of Jupiter at the moment, best time is really nice just before dawn, basically. And currently Jupiter is already at a very large 35 arc seconds and magnitude 2.1, and that diameter will only increase probably to around 45 arc seconds progressively as we get towards its opposition in February next year. So, two of the key planets, of course, for this month that we want to concentrate are Saturn and Neptune, which are both coming into opposition later in the month. Saturn on the 21st, and Neptune a couple of days later, I think on the 23rd. So currently, Saturn is rising early in the evening, and it's transiting at quite a reasonable, about 15 minutes to midnight. Its diameter is 19.5 arc seconds and a magnitude of around 0.6. Neptune, very close to Saturn, so it's transiting just about 15 minutes later. They're very close in the sky together, and that currently has a diameter of around 2.4 and a magnitude of 7.8. So Saturn itself, of course, very easy to find with the naked eye. It's currently between the circlet of Pisces and the head of Cetus there. You won't be able to miss it. It'll be a fairly bright star. Well, it'll appear like a bright star at magnitude 0.6, and it will usually has a nice yellowish sort of tinge to it. So, as we just remarked, Neptune is very close to Saturn. So, if we in fact look at this zoomed-in view, you can see the outer circle of this tellurad is actually 4 degrees. So it's 2 degrees from Saturn to that outer circle. So you can see currently Neptune is about maybe 2.25 degrees away from Saturn. So a good way to find Neptune, you could probably center your field of view on Saturn. And if you just gently make your way in this direction, which is sort of, if you draw a line if you draw a line between this star, Saturn, and that star in Seti, if you sort of move almost perpendicular, but maybe a bit this way, you should be able to stumble across Neptune. And you'll know you've stumbled across Neptune through a low field eyepiece on a still night. It will appear as a quite a deep red, steady star. And then as you increase the magnification, what you'll find is it'll actually become a nice little blue ball. So it's always a thrill to me to have a look at Neptune, and now's an excellent time to take a look at it. So we'll talk a bit about Neptune later. Main thing I wanted to concentrate on in this show, of course, we're used to looking at Saturn's rings, but at the moment, their tilt is nearly edge on. In fact, they were exactly edge on earlier in the year, but Saturn was too close for us to observe that. So at the moment, the rings have opened up just a couple of degrees again, then they'll close again towards the end of the year, and then finally they'll start opening again in 2026. So one of the fun things, just like Jupiter, is to look at the various moons of Saturn as they go around it. And at the moment, because we've got quite an edge-on view, the moons will often line up pretty much almost in a straight line, like you can see here. So in this example, for example, on the 12th of September at around 8 p.m., you can see there the 4 inner moons, Tethys, Enceladus, Dione, and Rhea, all in a line. And they're also joined by Saturn's biggest moon, in fact, one of the biggest moons in the solar system, Titan, which always has that nice orangey sort of color to it. And then here's an example on the 16th of September at 10 p.m. And you can see there are very different configurations. So Dione is now on this side, along with Enceladus and Tethys. Here you can also join by Mimas, which you can see on the 12th was actually in conjunction behind Saturn. And you can see Titan all the way over there to the right. So that shows you how far Titan can in fact move. So if you want to identify the moons of Saturn, a good way of doing that is to look on an app such as Sky Safari or or you could use Stellarium like I've used here, or various online websites, and you can actually get a configuration for the Saturnian moons. And also I've provided this table here for your convenience. So what this does is lists the bright moons of Saturn from the closest to the furthest away from Saturn. It also lists their magnitude to give you an idea of how bright the planets are, so you can sort of use their relative brightness to help identify them as well, and identify whether you're looking at a moon or perhaps a background star. And so, for example, in terms of magnitude, you can see here Titan, even though it's quite far away from Saturn, it is, of course, the brightest moon at a magnitude 8.4. And Rhea is the next brightest one at 9.6. And then the others progressively get fainter until you get to Hyperion, which is 14.4. So that's around the magnitude of Pluto. So not that hard to see under a dark sky if you've got, say, a 10-inch telescope or above, but you would need to know where to look to separate it from a background star. So, for example, if you happen to be out on the 16th at around 10 p.m. and it is clear, you can see there Hyperion happens to be quite close to Rhea there. And the other thing I wanted to point out is this maximum elongation. So some of the moons, so this tells you at its maximum extent how far these moons can move away from Saturn. So that can also give you help identifying them. So I've given you the maximum elongation in arc seconds and arc minutes, but I've also converted that to Saturn diameters, because that's probably a better way of assessing it in the eyepiece. So, for example, Mimas, the closest moon, has a maximum elongation of 1.5 Saturn diameters. And you can see here, that's a Saturn diameter. So we're talking about the diameter of the sphere there. And you can see there that at the moment, that's about 1 Saturn diameter away. So at its furthest extent, maybe it could go out to about here or so. So it's always going to be nice and close to the planet. Moving further out to, say, Dione, for example, that has a maximum elongation of 3 diameters. And you can see here, for example, on the 16th, that's about 1, 2, 3 diameters away. So this here on the 16th is probably as far as Dione is going to get away from Saturn. Titan, on the other hand, you can see there has a maximum elongation of around 10 diameters. So that's why over here on the 12th, even though it's quite close to Saturn, by the time you get to the 16th, it's all the way over there to the right of your screen, which is about, if you measure that out, is about 10 of those diameters there. So again, that's probably near its maximum elongation. And of course, you've got Hyperion, which has the very faint moon, has a very varying distance, similar to Titan. And also there's a moon, Ipetus, as well. So that's actually not super dim. It's only magnitude 11. So it's actually brighter than Enceladus, for example. But it has a high inclination, which means it's actually going to often appear outside the plane of these other moons. And also look at its maximum elongation. It's 30 Saturn diameters. So not only will it often appear well above or below the plane of the rings, it will often appear quite a distance away from Saturn. So again, to track down Ipetus, you'll probably need the assistance of some sort of app or diagram to find out exactly where it is. So I think most of you will be familiar with the types of events that we can observe with the Galilean moons of Jupiter as they go around the planet, such as transits, shadow transits, and eclipses. So one of the most exciting things about Saturn being relatively edge on to us at the moment is we can also observe these things occasionally with Saturn's moons as well. Normally we can't when the rings are open because we're outside of that plane. So from our viewpoint, we can't see these things. So the easiest events to see of Saturn's moons are those ones involving Titan, because Titan is by far the largest of the moons and also the brightest. Unfortunately for us, particularly in the Southern Hemisphere, there's been very few such events that have been that basically occur when Saturn's visible at night, in particular. And to my knowledge, the only one for this year that's for the remainder of this year is on the 20th of September, but even that's not well placed. I think in the eastern suburbs states of Australia, it's just viewable in the very early evening sky, just as the just almost in twilight. But for us here in Adelaide, the sky will be too bright, so we won't be able to view that one. So as a second best, I've identified two shadow transits of Rhea, which is the next brightest moon of Saturn. So if we just whiz back to this table, so Rhea has a magnitude of 9.6, but it's also considerably smaller in terms of angular size. So the events involving Rhea will be considerably more challenging to observe. I've never observed such an event, but I think it's worth a try. I have read reports of people being able to observe shadow transits of Rhea through a 6-inch refractor, but it was very challenging. So I think if the sky conditions are ideal, and particularly if you have a larger telescope, I think it's well worth taking a look at. So the first event is on the 18th of September. So mid-transit, that's where the planet and its shadow will be roughly at the midpoint on Saturn, will be around 1857. And the event will end, the egress, or in other words, when the moon and its shadow exit the face of Saturn, will be at around 2048. So I've just shown you with these arrows roughly where to look. And I've also on this top diagram here shown you the positions of the moons of Saturn at that time, so that you'll be able to orientate yourself. So Titan will be right over here to the right. Dione and Enceladus and Mimas will be here closer to Saturn. And then you have Tethys on the left. So you'll be wanting to look underneath the ring, assuming that these moons are on the right. The transit will begin about here, and then the moons will move across. Now, the contrast will be very low, so you'll need to use as much magnification as you can possibly get away with. And it's unlikely, I think, that you will actually see Rhea itself in front of Saturn because there's not enough contrast. But you may be able to see the shadow because the shadow is so dark. So through this diagram you see here is, of course, greatly magnified. Through the view through the telescope, even at high magnification, it's going to be considerably smaller. So what you'll be looking for is just the tiniest of black specks. And the way to tell whether or not you're actually seeing the shadow is whether it's approximately in the correct position. And of course, if you observe it over time, check to see whether it moves. And if you see that it's slowly moving to the left, then you can be sure that you're actually seeing the shadow. So now just a quick look at the other event on the 27th. Again, I've shown you the configurations of the moons, just so that you know which part of Saturn you should be looking at. So this time, Dione, Tethys, and Enceladus will kind of be in a line here, and they will form a triangle with Titan, which you can see has now moved all the way over to the left side. Again, Rhea will transit underneath the ring. So mid-transit will be at around 1955. It will slowly make its way across until the egress at 2048. And notice in this case that with the previous transit, the shadow was kind of moving in front of Rhea. Now the shadow is moving behind Rhea because we're now past opposition. So the sun has kind of moved slightly to the other side. And again, I don't think you'll see Rhea itself, but look for a black speck. And if you see that black speck move, that means you're catching the shadow. And even if you don't see the black speck, be sure to study this side of Saturn towards the egress time, and you should suddenly see Rhea once it exits the disk of Saturn. It will suddenly appear a lot brighter. So if you didn't see it in front of Saturn, you'll certainly see it once it re-emerges, which should be quite spectacular. So these are two events. I've never observed such transits, but I'll certainly, assuming it's a clear night, be out there looking, and I hope you get a chance to look at it as well. If you do happen to see that shadow, congratulations. You're making an observation that very few other people have made in the past. So finally, if all that excitement looking at Saturn's moons isn't enough, because Neptune's so well positioned at the moment, you can also take a look for Triton, which I always find a very satisfying observation to see. Probably that Triton would be the furthest moon in the solar system that certainly you can observe through an amateur telescope. So Triton will appear very close to Neptune. It's relatively faint at magnitude 13.5, so certainly needs a dark sky, but also because it's so close to Neptune, you'll need plenty of magnification. So, for example, this shows you the relative scale, viewing it 270 times through a 12-inch telescope. And what I've provided you here is with a table showing the elongations for Triton, because when viewing such a faint object or a difficult to observe object, it's nice to know which side of the planet it will appear. So these dates that I've listed here are the best times to view Triton. That's when they'll be furthest away from Neptune. And I've also indicated whether Triton will be kind of on the south sort of side or the northern side. So the way to tell what is north and south is to basically center Neptune in the middle of your eyepiece, and then let, if you've got a dob, just stop tracking with your hands. If you've got a driven mount, switch the tracking off on your mount, and then allow Neptune to drift. So the drift direction, so that is the direction that you see Neptune moving through your field of view, that's always west. That's always good to know. So whatever direction an object goes through your eyepiece, that is west. And then to identify north, if you're looking through a reflecting telescope, a reflector such as a Newtonian, Dobsonian Newtonian telescope, north is 90 degrees anti-clockwise to the drift direction, and south is 90 degrees clockwise from the drift direction. Now, if you're one of those unfortunate souls that's looking through a diagonal, so that's a Schmidt-Cassegrain or a refractor, but you're also looking through a diagonal, because that actually turns your view upside down and kind of back to front, the north and south directions are opposite. So north will be 90 degrees clockwise to the drift direction, and south will be 90 degrees anti-clockwise. So I hope you find that useful. So while you're out there having a look at Saturn, be sure to swing your telescope a little bit over 2 degrees to take a look at Neptune and see whether you can make it that very satisfying observation of Triton. Our constellation of the month for September is Aquarius, which you'll find above the very recognisable Pegasus and the circlet of Pisces here. And we're going to look at 4 objects, 2 globular clusters and 2 planetary nebulae. So our first object is M2, which is over here. So I'll just zoom in a little bit. So if you go from a line from Epsilon Pegasi to Beta Aquarius here, about a third of the way along that line is M2. And apparently, I haven't tried myself, but under a really dark sky, it should be just visible to the naked eye, but you can certainly sweep it up in binoculars or a telescope. So M2 is a really nice globular cluster, one of the closer and the brighter ones. Also, it has a class 2, so globular clusters have a class rating from 1 to 10. It's somewhat arbitrary. It's a Sharpley classification. 1 means it's really concentrated. In other words, it's really ball-like with a sharp concentration towards the center. And as classifications get towards 10, they become much more looser and more like an open cluster. So the two globulars we're going to look at are sort of at those two ends of the spectrum. So M2 has a very high concentration. Like all globular clusters, it consists of very old stars. In this case, the average age is considered to be about 12.5 billion years. So you can see that's quite close to the estimated age of the universe, which is of the order of 13.5 billion years or so. So looking through any sort of telescope, you'll start to get partial resolution. And by the time you get up to, say, around a 10-inch or 12-inch telescope or so, you can pretty much resolve this wonderful globular cluster to its core. Now, the second globular cluster we're going to look at is M72. So that's good to contrast with. It's sort of on the other end of the spectrum. You can see there that it has a class of 9. And it's almost like an open cluster. In fact, if you look at a Hubble Space Telescope picture of it, it pretty much looks like an open cluster. And it's also considerably more distant at 55,000 light years away. So through the telescope, you're only going to get partial resolution. So even through, say, a 12-inch telescope or so, you're going to get some of the stars just resolving near the center and maybe a few around the periphery, but pretty much it's going to look very granular and unconcentrated. So those two globulars, M2 and M72, make a nice pair to see the differences at both ends of that concentration spectrum. Our next object is now going to be, oh, and by the way, M72, I should say, is up here in this part of Aquarius. And our next object is going to be NGC 7009, sometimes known as the Saturn Nebula. So this is a great planetary nebula of considerable historical significance because this is actually the first deep sky object that William Herschel discovered. So even though it has an NGC number of 7009, it was actually the first object in Herschel's catalogue that he actually discovered himself. And it was the discovery of the Saturn Nebula that then made him embark on his great endeavour to sweep the sky and discover thousands of other deep sky objects. In fact, most of the objects that we see in the NGC catalogue. So the Saturn Nebula, up the top, there's a close-up photo of it through a professional telescope. That view you see there down the bottom, kind of that blurry sort of view, very much like it often looks through the eyepiece. So it has this beautiful blue-greenish colour. Always you can see an elongation in the east-west direction, and sometimes at high magnification. So you can see there in my 12-inch, for example, I had to use around 333 times. You can actually see those faint extensions at each end. And also, even though I didn't see any detail in this case, sometimes on nights of really good seeing, you can see some detail in that central disk, but I don't think I've seen the central star. And our last planetary nebula is one of my favourites, of course, which is the Helix Nebula. So that is, I believe, the closest planetary nebula to us. You can see there the distance is a relatively close 530 light years. And the main thing to note about the Helix is look at its size. So whereas the Saturn Nebula is 28 arc minutes, so that's, let's call it half an arc second. So a little bit, maybe 50% bigger than the disk of Saturn, for example, the Helix Nebula is 16 arc minutes. So that's very large. So the full moon, is around 30 arc minutes. So that's about, the Helix Nebula in the sky is about a quarter of a moon diameter. That's huge for a planetary nebula. So even though it has a bright magnitude of 6.3, it has a very low surface brightness. So to get a good view of it, you absolutely need a dark sky, and an oxygen-free filter really helps in that regard. So through a 12-inch, for example, note the low magnification of 62 times. With an O3, it appears as basically a huge smoky ring. I don't think I've ever seen the central star. Not that I can recall anyway, but certainly the central region appears much darker, almost black. And on a night of good seeing, not only can you see that pinched corner on one end, but you can actually see all of these little dark areas that you can see in that photo there in the ring. You see those dark areas sort of punctuating and riddled throughout the ring. So it actually looks really smoky. So it's a really fantastic object to take a look at, as long as you have those nice dark skies. Thank you very much for joining me in today's show. I really enjoyed putting it together and presenting it for you. Hopefully we'll get some clear nights so that you have an opportunity to look at those Rhea transits in particular, and also get out and look at some of the wonderful deep sky objects on view at the moment. So until the next show, I wish you clear skies, and bye for now.